All right, so now we move on to the last and final unit, Unit 5 Relations, which is the last unit that is included in your final exam. All right, so we look at what happens in relations, and we're going to deal a lot with linear relations, meaning how do we graph certain linear lines, and then what does that mean in certain contexts. We're going to talk about independent variables, dependent variables, outputs and inputs, and much more within this. Okay, so when we start off with linear relations, a water tank has a starting volume of 200 liters. The tank is being filled with water at a rate of 50 liters per minute. The total capacity of this tank is 1,000 liters. Okay, create a table of values for these given time periods, 0, 1, 2, 3, 4 minutes, and then use the volume to describe whatever is happening after that amount of time. Okay, so what we're going to do in the table here, we're going to fill this all out. We're going to put in 0 minutes, 1 minute, 2 minutes, 3 minutes, 4 minutes, and 5 minutes. Well, they tell us at time 0, it starts at 200 liters. They tell us that right in the first line here. They say starting volume is 200 liters. So I'm going to put at 0 time, we're at 200. Okay, it changes at a rate of 50 liters per minute that passes. Okay, so what we're going to have to do is say, well, after 1 minute, how many? We add 250. So 200 plus 250 is equal to 250. We add another 50, which gets us to 300 after 2 minutes. After 3 minutes, we've seen a total of 150 added to the original, which would put us at 350. We then go to 400 because we add another 50 after that next minute. And then at 5 minutes, we could say this is up to 450. Okay, now what we should probably put here is that there's a capacity of 1,000 liters. So we know there's going to be some endpoint here. It only goes as high as 1,000. And once it hits 1,000, we know it's reached its max. So what we could do is realize this, is that if the pattern continues on and on and on, well, we're going to reach up to 1,000 liters, and that will be after a certain amount of time. Let's see if we can graph this here. Okay, so we have to recognize that these are ordered pairs where the time is always represented by our x value. The volume or the output is always represented by our y. So let's put this on the plot here. If we know that it starts at 0, 0, and volume is going to be our y, and time is going to be our x-axis, which that will always be the order. Now what do I want to do is put this on the graph. So after every little hash here, I'm going to put 1, 2, 3, 4, and then maybe 5 at the end here for time. So that's in minutes. And then volume, which is in terms of liters, we're going to go from 200 to 250 to 300 to 350, finally to 400. Now, as long as these are evenly spaced, meaning between each unit you have equal spacing, it's perfect. So you could make this shorter, like you could shrink this in so that it's all contained within this part below here and this part below here. That would be totally fine. You just have to make sure that whatever the spacing is between your 2 points, it's consistent from one to the next, one to the next, one to the next. Okay, so now when we plot this, at 0, we're at 200. So I'm going to plot this in red, 0 and 200. 1 and 250, 2 and 250, 2 and 300, my bad, 3 and 350, 4 and 400. And then in terms of 5, it would be off the graph somewhere. Now they say list the ordered pairs. What I'm going to do is I'm actually going to put them directly on the graph. So we know that in terms of x and y, or t and v, it's 0 time equals 200 liters. We then go up to 1 minute and it's 250 liters. We then go up to 2 minutes and it's 300 liters. We then go to 3 minutes, which is 350 liters. And finally, we go to 4 minutes and that is 400 liters. All right, now that's all the ordered pairs there. Determine this for the following situation. Output values, input values. Our output values are always whatever we take from our x-axis, that determines what the output values are, which are on our y-axis. Our output values here are actually all the y values, or more specifically, the liters at each of those points. So we have 200, we have 250, we have 300, we have 350, and finally we have 400. And then when they say the input values, that's what we input to the problem. Time is the part that we're inputting in here. After a certain amount of time, then the volume changes. So our input values are 0 minutes, 1 minutes, 2 minutes, 3 minutes, and 4 minutes. The independent variable. Our independent variable is always found on the x-axis, and it's what we input to the problem. After a certain amount of time, this happens. So we know that it's going to be our time variable, which corresponds with our x. We then look at our dependent variable. Well, depending on the time that passes, we have a certain output, which is our volume. Volume corresponds with the y points. Is this discrete or continuous? This should definitely be continuous. Anytime you see time involved, you immediately know it's continuous. And now, are the dots connected? Yes. Why? Because it is continuous. As soon as you know it's continuous, this should be connected. Thus, we're actually going to go back up to our graph here, and I'm going to draw a straight line that connects all of these points together. Because we can break down time infinitesimally, meaning I could really have like 1.11111 seconds, 1.000246 seconds. You can break down time infinitely into the smallest incremental levels, meaning that line will continue infinitely. And because it's connected like this, you could technically have the smallest subset of this. So at like 0.5 minutes or half a minute, you would have a certain amount. At a quarter of a minute, you would have a certain amount of volume. After 0.75 or 3/4 of a minute, you would have something. Maybe after 3.5 minutes, you have another thing. The water flowing in is a continuous rate. And as soon as you know time's involved, you can basically say this is continuous for sure. All right. Now, choose the equation that matches the graph. Okay, so remember, our equation always boils down to y is equal to mx plus b. Now you're saying, okay, well, what is y and mx plus b? What do all these symbolize? Well, if we go off to the right here, m is always symbolic of the slope. So whatever the slope of our graph is, that's the m value. Our b value is equal to our y-intercept. So if we have a certain y-intercept for the problem, that's our b value. So what we're going to do is we're actually going to go back to the previous problem and we're going to figure this out. Remember, our y is corresponding with our output or our volume. Our m is our slope. X was symbolic of the time or the input plus b. So we need a couple things here, and we're going to go back to our graph and make sure we get them here. So in terms of the slope or the m value, we're going to do it in blue here. Between any 2 points, let's say I choose these first 2 points. How much do I have to rise by? Well, I increase by 50 liters. How much time passes, or when we go from the left point to the right point? 1 minute passes. So when we talk about the slope, m is equal to 50, which is our rise, over our run, which is 1. And more formally, we know rise over run is symbolized by a change in y over change in x. Our rise over our run. There we go. So that's our m value is equal to, simply we could actually even just put 50, because anything divided by 1 is just itself. Now our y-intercept, it appears right here. This is where it crosses the y-axis. What is that? It's a y value, or our y-intercept is equal to 200. So our b value is equal to 200. Now, if we go back to the equation, we need to find a slope of 50, a y-intercept, or a b value equal to 200. Let's see which one it is. So I go along the list here and I say, okay, well, in the first one, we have the correct v, which is our output. We have our input variable in the equation, which makes sense. Our slope was 50 though, so that doesn't make sense. So we have to go to one where 50 appears connected to a variable, but so that eliminates these two right away, which we could actually just cross out in red, eliminates these two. Now we look at the other two. Remember, this has to be our output variable. Time was not our output, so this is not the possibility. Therefore, our equation is simply this one here, which I'll circle in blue. Okay, in how many minutes will the tank be full? What is the volume of water in the tank after 12 minutes? Okay, so kind of a two-parter here. How many minutes will it take to be the tank full? Remember from the previous page, they said the tank fills, it's full at 1,000 liters. Once we hit 1,000 liters, that's done. So for part A, we're going to say volume equals our slope, which is 50t, plus 200. Our volume is 1,000, which is equal to 50t, plus 200. And when we do equation work like we did in our last unit or last review, you'd realize to isolate for t, we're going to have to subtract 200, and 1,000 subtract 200 is 800. And then this is equal to 50t. And now we have some variable that's attached to some coefficient. And so when we take that 50 and we divide it by both sides, so we divide 50, we divide 50, well, 800 divided by 50, we're going to get an answer of 16. So time is equal to 16 minutes. And we're going to say 16 minutes to fill. So that's for our first part, is we know it's going to take 16 minutes to fill this tank. But then they ask, well, after 12 minutes, how full is it? So instead of substituting in some value for V, now we're solving for V. We're saying volume is equal to some amount of volume after a certain amount of time. So I rewrite the original equation and then I put at, in this case, they say 12 minutes, which is equal to our T value. We're going to sub that in and find a volume, 50 times 12 plus 200. Therefore, the volume at 12 minutes is equal to, well, if we do 50 times 12, we get 600, and 600 plus 200 is equal to 800. So our answer is a volume of 800 liters at 12 minutes, which I could further emphasize below here, at 12 minutes. All right, now dealing with the Cartesian plane and dealing with points, we want to plot the following points on the graph and then say, hey, what quadrant are they in based on where they were plotted? Remember, ordered pairs are always written as x first, y second. So when we look at the above, what we want to do is we want to say, okay, if we look at each of these and plot them, we're going to start off with looking at x, then our y. So in the first point, it says 4 and 4. We go to 4 on the x, 4 on the y, and where those two cross is right here. So that's our first point. What quadrant is that? That is quadrant 1. That is the first quadrant. And remember, quadrants are labeled in terms of the top right is 1, and then going counterclockwise, you get 2. So we start with 1 in the top right, then we go counterclockwise and get 2, 3, and 4. Okay, now we're going to do the same plot method that we just did with the other point. I'm going to go to -2 for x, and then +2 for y. That puts me at a point right here. And that would be quadrant 2. All right, next point, we go to -1 and then -4. Where do those two overlap? Right here on this point. So we're going to find that that is in quadrant 3. And then lastly, we go +3 in the x, and then 2, -2 on the y. So here and here, and their intersection point lies within quadrant 4. So we can put quadrant 4 like that, and there we go. So just remember, x always comes first, y comes second, and you're plotting where they overlap. Okay, determine the x and y intercepts of the following graph. Okay, well, we're going to start off with graph number 1. X-intercepts are where they cross the x-axis. So if I draw a line across the x-axis, well, where does this graph cut through the x-axis? It would be right here. And if we look at this graph, it's actually right on the origin, or what we like to call here as 0 and 0. It's the 0, 0 point. It's the origin. So when they say the x-intercept, it is an x value equal to 0. The y-intercept is actually the same thing for that first graph. We realize that when it crosses this axis here, the y-axis, that point is right here. So we go over and we say that y is also equal to 0. They share the same intercept. Okay, graph number 2. Graph number 2 says, yeah, we want to look for our x-intercept. Our x-intercept occurs when it passes the x-axis. That is right here at x equals +2. So x equals +2. We then go to our y-intercept where it crosses the y-axis, and that is specifically right here. What value is that? It is -4. So y is equal to -4. All right, now we have a vertical line. And if you remember from the year, a vertical line is always an undefined slope. Here's why. And maybe we'll explain this even further in the notes in the review here. But when we have a vertical line, we want to think about the slope here. M is always equal to the change in y over the change in x. Suppose I gave these 2 points on this line. Well, we would know it increases by a certain amount of y, but it doesn't move left or right. This is not possible. It does not move left or right. So when we put it into our slope, it would definitely change by some amount of y units, but nothing in the x value, and we can never divide by 0. This is an undefined line. Undefined. So when we look over, and that's just totally a tangent to this, it is important knowledge, but it's a tangent to our x and y intercepts. On graph 3 here, I'm just going to erase this piece here, and we're going to speak strictly about the x and y intercepts. Well, we know of this line. It crosses through the x-axis right at this piece here. What value is that? Well, that's x equals 3. So we're going to put x equals 3. And then when we look at our y-intercept, well, does this line ever cross the y-axis? No, because it's directly vertical. It actually runs parallel to the y-axis, meaning it will never cross. So we say no y-intercept, or simply none. Lastly, graph 4, we see a horizontal line speaking on this slope. Suppose I chose this point and this point. Well, if I look at this, there's no vertical change. There's no vertical change in that height, but there definitely is some amount of change in x. So when we calculate slope, we would say m is equal to the change in y over the change in x, which is equal to change in y is 0 over change in x to some amount. Well, anything divided by, or any 0 divided by some number is just simply equal to 0. So we would know the slope is equal to 0. Now, again, that's just a tangent to that problem, but it is important knowledge for this unit of relations. So we have a horizontal line. Where does it cross the x-axis? Well, just like when we had a vertical line, this one is not going to cross the x-axis. It runs directly parallel. So therefore, when we have a horizontal line, there's no x-intercept. Now, y-intercept, what is it? We look across this and we say, where does it cross the y-axis? Well, it's right at this point here, and that's a value of positive 4y. So we can say y is equal to positive 4. All right, slope characteristics and finding slopes of graphs. In which of the following does the slope of the line L equals 0? Well, we actually just alluded to this. We went over this concept. In the first two, right away, you should be thinking there's no way those slopes are 0 because they represent some line, some oblique line that is going to go left to right or in some way. So either a positive slope or negative slope. Remember, in the ones that look like this and they decrease going left to right, this is considered to be a negative slope. The ones that increase in a left to right manner like this are a positive slope. So right away, cannot be A or B. Now we go to C or D. Remember, a vertical line, we actually just discussed, this is an undefined slope. Undefined because we end up dividing by 0. There's no change in x versus this is equal to some no change in y because our line is strictly horizontal. We don't change in the y, but we do change in the x, meaning this is 0. So horizontal lines, and I'll write it above, horizontal lines have a slope of 0. There we go. So it is definitely, in this case, for our answer, D. All right, in which of the graphs is the slope negative? We actually just covered that right above. If we're specifically looking for this line to decrease when going from left to right, the one that does that is, when we look here, this one is going down from left to right, meaning it is automatically the answer. That's your first giveaway. It is a negative slope because as we move left to right, it is decreasing. Which of the lines has a slope of negative 1/2? Well, if it's a negative slope, is it ever going to increase left to right like these graphs? No, these are bad solutions. Those are not ones that we want to look at. A and B are out of bounds because they are positive slopes. These are both positive solutions. So there's no way a slope could be a negative 1/2. Now, when we talked about this in class, a really fast way to look at these and determine the slope and see if it's correct is the more up and down, or strictly, the more vertical a line gets on the graph, the actually more positive it becomes. So rather than it being just, like let's say I looked at this slope, I would assume this is somewhere in the integer values. It would be something like a slope of 2, 3, 4, maybe even greater. The flatter the graph goes, or the more horizontal, the less the slope is, meaning it's going to become some fractional amount. So right away on surface level, I'm thinking we should circle this one, C, because it's flatter, more horizontal, and it also, on a left to right basis, is decreasing. But let's confirm that on the graph. If I look at these 2 points, I'm going from -1 to +1. The vertical change when we go left to right is the following. I'm going to go down 2 and then over by a certain amount. When I go down 2, I'm going to put a -2 here. And then how much do I go left to right by? Well, as I go left to right, or as I follow the blue line here, I'm moving 1, 2, 3, 4 units. So I'm moving 4 units to the right. When I put this in terms of a rise or run, well, the slope is equal to the rise, or the change in vertical height, over the run, which is 4, and as a fraction, this reduces to 1/2. So definitely this is the correct solution. Now, you could also move on these points in a right to left manner, upwards like this. However, I think it's better just to get in the habit of saying, hey, if this thing goes left to right and it's decreasing and it's pointing down, I know it's a negative slope, and thus I'm going to calculate it as how much do I go down by, how much do I go over by, and strictly thinking about it in terms of the Cartesian plane. If I go down, it's negative. If I go right on a number line, it's positive. All right, the accompanying figure shows the graph of an equation x equals 5. Whenever we have a vertical line, we always know the equation is in terms of x. That's a really important thing here. The equation is always in terms of x. Okay, what is the slope of the line x equals 5? Well, let's calculate the slope. And we've actually done this. We've shown that it's undefined, but I want to make sure we're okay with this. So we say m is equal. I'm going to choose 2 points. I'm going to maybe choose here and here. Well, if we look at this, in terms of an xy ordered pair, this is going to be 5 for x, and then we go down to -3. In terms of this point, it is 5 for x, and then in terms of y, we are at 4. Okay, what is the vertical change in this? Well, the change in y is equal to, if I go from -3 up to 4, I've went 7 units vertically. But then my change in x, I don't move left or right. There's no left to right movement in this case. So what I'm going to say is that the change in x is equal to 0, but because I can never divide by 0, therefore this is undefined. This is an undefined slope. Any vertical line is an undefined slope because we cannot do this dividing by 0. That is not allowed. And maybe I'll be a little more clear with that symbol. I'm going to put a circle, cross it out. We cannot divide by the 0. What is the slope of the line L? Okay, the slope of the line like this, what we could do is we could use slope formula, or we could just simply say, hey, rise over run. How much does this go up? How much does it go over by? I'm going to put 2 points here, one here, because those are the listed ones, and they even give us the ordered pair. They're pretty generous with that. Order pair 1, order pair 2. So what we can do here is we can say, how much does it go up by? Well, it has to increase by from -4 to 0, +4 units. How much does it have to go right by? From 0 to 3, it goes +3 units. So now when we talk about a slope, m would be equal to 4 divided by 3. Now that can't be reduced anymore, so there's the slope. Here's the other way we can solve for this. We can use those 2 ordered points they gave us and say m is equal to y2 minus y1 over x2 minus x1. Therefore, the slope is, I'm going to deem my right point as y2. So y2 is equal to 0. y1 is equal to -4. So now I'm going to go 0 minus a -4 over. Now, if this was my second point, x2 is 3, and then x1 is 0. So then I go 3 minus 0. Therefore, the slope is equal to 0 minus -4, which is +4, and then 3 minus 0 is 3. And therefore, do we see how these 2 slopes are actually equal to each other? I could solve it using our slope formula Or I can just do simply rise over run. How much does it change vertically? How much does it change horizontally? All right, now for this one here, we could use our slope formula, which maybe that's what I'll do, but I can also demonstrate it in the both ways just to make sure we're okay here. So they give us points A and B. A and B, where this is the origin right here. So I'm gonna put the ordered points for these, or the ordered pairs, I should say. In order to get B, I go over 2 units, and then it is vertically 3 units. So I have a point at 2 and 3. For A, I have an X value of -1, a Y value of -3. I'm going to denote this one as my point 1, or my ordered pair 1, and I'm going to order pair this as the second point. Now, as a rise over run, or a simple increase vertically over an increase horizontally, when I go up from A to B, I have to increase from -3 to 3, which means that I'm going up 6 units. So slope, which is equal to the change in Y, is equal to 6 units. But then I have to do it over the amount that's changing in X. How much am I changing in X? When I go from -1 to +2, so if I've gone up 6 units, I have to go over by -1 to 2, which is +3, and therefore I put 3, and this simplifies to 2. Now in my slope formula, we have y2 minus y1 over x2 minus x1. That is equal to, well, if I go by the points that I've labeled here as this is the second point, this is the first point, that means my y2 is 3, my y1 is -3. So I'm going to say this is 3 minus a -3, all divided by my x2 is 2, my x1 is -1, and so I go 2 minus the -1, because the negative is inherent in the formula. The negative exists right away. So if you're wondering why I'm putting a negative here, that is why. Now, this is equal to 3 minus 3. That turns positive, just like the denominator turns positive. And we get 6 over 2, or 6 over 3, my bad, which is equal to 2. Yet again, you can see we get the exact same number. So whatever one you find easier, if you want to just go rise over run, or if you want to use the slope formula, which is slightly more difficult but gets you the same answer, perfect. Now, I will say this formula is really important, especially when you're not given the graph and you're just given points. You'll need to use this formula. But if you're given the graph, go ahead and just say rise over run, get your solution. Okay, draw a line that passes through the given point with the given slope. Label each line with its letter. Okay, so we're going to put A, B, C, and D all together on this one graph. Okay, and I'm going to try and use different colors here. What you want to do is you always want to plot the first point that they give you. So they give you these points for all of these lines. And what we're going to do is we're going to put all of these on the graph as our first part, and then use the slope to get a second point. So starting with A, which I will do in blue. -7 and 2. Remember, ordered pairs are always in terms of X and Y. Okay, so we go over to -7 for our X and down to -2 for our Y. Here is the first point of A. We then use the positive slope to say, okay, to get our second point, I'm going to go 1, 2, 3, 4, 5 vertically, because remember, slope is change in Y over change in X. So we go up 5 units, to the right 4 units. 1, 2, 3, 4. Perfect. Now we have a second point here, and what I'm going to do is I'm going to just draw a straight line right through these 2 points. Once I've created those 2 points, I have my line, and then remember, this could technically go on to infinity, so I'm going to put that line here, and we're going to label this as A. Okay, then we go to my next point, -5 and 6. I'm going to do line B in red, -5, +6, which puts me at a point right here to start B. We have a slope of -2. What is that technically? That's a slope of -2 over 1. Or we go down 2 units over 1 unit, meaning I'm going to go down 2 units over 1 unit. There's a point. And I could do another point, down 2 units over 1. There is a third point for that graph. So I'm going to just take a line, connect it through these as following. I'm going to put arrows on the end, 1, 2, and then I'm going to say that this is graph B. All right, for C, what I'm going to do is I'm going to change my color to green, let's say. And I'm going to use that first point of 5 and 4, which puts me at 5x, 4y. And now I need to do a slope of 0. Remember, in our previous discussions, a slope of 0 means that this line strictly is horizontal. Undefined is when it's vertical. Horizontal is when it's a slope of 0. So what I'm going to do is just draw a straight line right across. That's a fast thing I can do here, and I can say that this is C. I don't even need to do a second point, because if I know the slope is 0, I can just draw a direct horizontal line. Now, my last one, I'm going to do this in, let's say I'm going to use the salmon color here. Okay, I'm going to go to 3 and negative 2, or 3x negative 2 for y. That's my first point. Undefined slope means there's no change in x. So what I can do is right away, I can just draw a vertical line like this. I can put my endpoints here, and I can call this D. That is an immediate thing. Now, just to expand our knowledge here, what I could do is I could actually put an equation for these graphs for the slope of 0 and undefined slope, because these ones are actually fairly easy to do. So when I look at D and I'm looking at the undefined slope, undefined slopes or vertical lines are always defined by whatever x value they cross through. In this case, it crosses through 3. So our equation for our graph is simply just x equals 3. X equals 3 is the only outcome, therefore that is what our solution is. Whereas with C, when I flip back to green here, it only crosses through positive 4 for y, and that's the y-intercept, but there's no other point than that, and there's 0 slope, meaning y is equal to mx plus some slope. Y is equal to, that slope is gone. There's no slope here. So I'm actually going to just totally cross that out, and I'm only left with my b value, which is positive 4. Now, the other ones, you need a little bit of work in order to get those equations, because you'd have to piece together that equation and make sure we get a slope and a y-intercept. But in the case of those two, those ones are easily identifiable. All right, arrange the slopes from the flattest to the steepest. Now, this is what I said before, is anytime the value is very high, what does that mean? Well, it's technically, if we wanted to put it, this is 5 over 1, this is 1 over 1, this is 0 over 1, this is negative 2 over 1. The larger the value, the larger or the steeper the slope. So when we want the flattest to the steepest, when we want it in that order of most horizontal, which I'll kind of just draw like this over, to the steepest, which would look like that, what we want to do is we want to pick out the smallest fraction, or the one that would break down into the smallest numeric number, to the highest number. And it doesn't matter positive or negative, because whether it's positive or negative has no impact other than saying that from left to right, it either increases or decreases. So here's what we're going to do. We're going to look down the line and we say, okay, which one is the smallest number technically if I was to calculate it? Well, that would be actually equal to negative 1/2. That would be, or I guess in the case we have 0, we could start at 0, because 0 is technically our smallest number. That's completely flat. So when we say our flattest, which I'll symbolize by F at this point here, we're going to start with 0, and I'll put steepest over here with S. So from flattest to steepest, 0 starts. Then we go to negative 1/2. That's the next smallest number. Then we go to 3 over 4, which is the next smallest number. Then we go to, in this case, 3 over 2, which is the next. Actually, no, we have 1 available. 1, then 3 over 2. Then we go to negative 2. Finally, our steepest line is 5. So I'll space this out just a little bit more here. Our steepest is 5, and then we can cut that off here. There we go. So just remember, flattest is the lowest number, meaning we start at 0 and then we start working our way up by decimal. In terms of decimal, 1/2 is smaller than 3/4, which is 0.25. 1 is technically smaller than 3 over 2, which 3 over 2 is 1.5. 1.5 is less than 2, and then 5 is greater than negative 2, and it's greater than all the other numbers here, so we know that this is in the correct order. Now, if you really wanted to, what you could do is just draw these out on a graph. What type of slope does 1 make? What type of slope does 1/2 make? You would find that you could draw these quite easily. All right, slope formula. We actually used this a little bit above. What we're going to do is compare slope formula and then just calculating slope by just simply saying rise over run, and we're going to see that they're actually the same thing. Okay, so let's do this example here. They want us to get the coordinates or the ordered pair for A and B. So below, what I'm going to do is say the ordered pair for A and B, well, that's saying 3 for X, 2 for Y. For B, we go over to 8 in terms of X, and then in terms of Y, it is 6. Okay, so we're going to fill those out here. We have 3 and 2 for A, and then for B, we have 8 and 6. Awesome. Okay. Now, slope of the line is rise over run, change in y over change in x. The change in the y coordinate, when we go from A, which is 2, to then B, which is at 6, how much did we go up by? It was 4 units. So the rise is 4 units, or the change in y, which is equal to the rise. The run, which is the change in the x, well, from A, which was 3, to B, which is 8, what does that change? From 3 to 8 is a change of positive 5. So the change in x is equal to 5, which is equal to the run. All right. So in this one, I think it's important that we just need to make sure that in terms of the slope, we actually need to make sure, because all they said was rise and run, I'm going to put this together to say our slope, or m, is equal to the change in y over the change in x, which we know is equal to 4 over 5. And 4 over 5 can't be reduced, so there is our slope of that line. Now, 4 over 5 is something less than 1, meaning it's actually should be a quite flat line, which makes sense. We don't have something that's pretty vertical. This one is actually pretty horizontal for a typical slope. So the fact that we have something that's less than 1 or some decimal value makes sense for this. Whereas if we saw a graph that was like this and we got something less than 1, well, that would go back to our previous example and say, is that right? No, because the greater the value for the slope, the more vertical it is. The something that is less than 1 should be more horizontal. Okay, what is the slope of the line that passes through these 2 points? This is where we need our slope formula, and this would be something that you will need to use. M is equal to, now we have to designate 1 as 0.1, 1 is 0.2. Now, what I always recommend is that when we think about the left to right structure, the left point includes the x value that's the smallest. When I compare 5 and -4, what's the smallest x value? It is this one, -4. So I'm going to make this 0.1, this 0.2. When we plug it into our formula, well, we know our formula is equal to the change in y, which is y2 minus y1, over the change in x, which is x2 minus x1. In the formula, well, x2, or y2, my bad, is 3. y1 is 1. So we're going to take this and go 3 minus 1 over. Now I'm going to go to x2, x1. x2 is 5. x1 is -4. When I put those two things together, it's 5 minus that -4. And this is going to be equal to 2 divided by 5 minus -4. That's like saying plus 4. And that would be 2 over 9. So we actually get a positive slope here. We get something that increases when going from left to right, or a graph that specifically looks like this. From left to right, it is increasing because this slope is a positive slope. Now, another way we could have done this is, they say just determine the slope. What we could have done is simply just looked at this and said, well, what is the change in y? And I'll even do this off to the side here, just as like, or maybe above. If I look at this, from this point of y and this point of y, what's the difference from 3 to 1? Well, that's a difference of 2, a change in y of 2. All over the change in x, well, what is the change of x in this problem? We go from 5 to -4, that's a difference of 9. So we can put over 9. Now, what I'd always recommend is that formula, you can make mistakes very easily in terms of making it either positive or negative, depending on the way you do it. So I would say if you're just strictly given 2 points like that, please don't just short form it. I would put them right into this formula and then make sure that whatever order you put them in is based on the fact that it's the second point minus the first, second point minus the first. Because if you mix up that order, you might get a negative slope when it's actually positive. All right, if the points 3, 2, and x and -5 lie on a line whose slope is -7 over 2, then x equals. So what they've done is they've said, what if I give you these 2 points and they lie on the same line? They create some line like this, but then we don't know one of the coordinates, in this case x. what we have to do is use the slope and slope formula to help us with this. So from the problem, slope, which is equal to -7/2, is equal to, now what we want to do is designate one of these as 0.1, one of them is 0.2. Now it doesn't really matter which one, just pick one. This is 0.2, this is 0.1, or 1 and 2, my bad, in that order. Now, like I said, it doesn't really matter, you can choose either way. So in terms of change in y, well, I go the second y, or y2, minus y1. So it's going to be -5 minus 2 divided by, now we look at our x's. x2 is equal to x minus x1, which is equal to 3. So we go x minus 3. Now, the nice part about this is we can combine our numerator terms. -5 minus 2 is -7 all over x minus 3. And now, to get these out of the denominator, we're just going to cross multiply. We're going to take everything that was in this denominator, multiply it here, everything in this denominator, and multiply it up here. Now, that's a short for saying it's the LCM, but we just want to continue forward with this. As soon as you have a fraction and another fraction and they're equal, cross multiply. That's going to give me -7 times x minus 3. Remember, it's multiplied by everything there, is equal to 2 times -7. Well, 2 times a -7 will give us some answer. When we distribute this -7 into the brackets, we're going to get a value of -7x, and then -7 times another -3, that's +21, which is equal to -14. Now, carrying this above here, we're going to continue this above. We have 7x plus 21 minus 14. What I'm going to do is I'm going to subtract 21 from both sides, because our whole goal is to isolate for that x. When I subtract by 21, I'm going to get -7x is equal to, and when I do 14 plus another 21, because that's technically what it's doing, it's just a negative number, 14 and 21 come together and they make 35. So we would get -35 here. Lastly, just like we did in equations, we take the coefficient that's attached to that x and divide it, including the negative. Therefore, x is equal to negative divided by a negative, which is positive, and 35 divided by 7 is equal to 5. So the point x, or the x value in this, is actually equal to 5. So when we go to our answers here, we can feel confident in circling A as our solution here, and I'll make sure that's a little neater here. There we go. All right, the line that passes through these points and has a slope, what is the value of y? It's actually the same problem. Now they're just saying, instead of calculating for x, let's calculate for a y value. So we're going to do the same thing that we did in last problem. We're going to use that slope formula, but I also want you to pick out right away, say, this could be 1, this could be 2. Now, order doesn't really matter as long as we keep them in that order when we do the calculation. So slope, or m, is equal to, they told us the slope from this problem is equal to 2, so we're going to pull that in. 2 is equal to, and now it's the change in y over the change in x, or y2, which is y, minus y1, y minus 3, divided by, now we're looking at the x's, x2, which is 2, minus x1, which is 1, 2 minus 1. We're going to bring these things together. So we're going to go 2 is equal to y minus 3 over 2 minus 1, which is 1. And just like we did before, what we could do is treat this like 2 over 1 and cross multiply. 1 times 2, 1 times y minus 3. This is going to be 2 times 1, which is 2, times 1 times y minus 3. Well, that's just the same thing. And then the very last thing we got to do here is just add that 3 to both sides, because we want to completely isolate y. So, therefore, y is equal to, well, if I add 3 to both sides, that's going to give me a value of y being 5, and that would be the missing value in that point. Prove that the following sets are collinear. So what it means to be collinear is to say, well, what if I had this line here? Collinear, by definition, says those 3 points would all be on the same line, where their slopes between any of the given points. It could be between those two. It could be between the very end points. The slopes are all the same. So if that's something you need to write down, the slopes are the same. Because if they share the same line and all those points are on that line. Well, a line never changes its slope. It's not like all of a sudden, if I'm up here and then I'm comparing to here, the slope doesn't change. It's still a linear line. Similarly, if I was down here and I compared to here, the line still holds constant. That line and the slope will stay the same. We're not dealing with graphs that are parabolic or even something like a square root of x graph that would look like this. The rate of change is consistent. So when you think about collinear, think about consistent slope or same slope. Okay, to test this, here's what we're going to do. I'm going to make this point 1, this point 2, and this point 3. We're going to create a comparison between 1 and 2 and 2 and 3. And if that parallel exists, if the slope between 1 and 2 and 2 and 3 exists, then we know they're all collinear because by the transitive property, because they're both share the slope that's between the point 2, we can figure out that that would make sense that 1 and 3 would also have the same slope. We just need to create a comparison that involves the same point twice. Okay, so in the first slope calculation, we have m is equal to, well, y2 is equal to 0 minus y1, which is negative 1, over x2, which is negative 1, minus x1, which is negative 3. This is going to simplify to a slope of minus minus, which is positive 1, over minus minus, which becomes negative 1 plus 3, that is equal to 2. So we get a slope of 1 over 2. Now, we have to confirm that between B and C, they also share that same slope. So we're going to go m is equal to, this is our second point, this is our first point in the calculation. y2 is equal to 1 minus 0, which is y1. 1 minus 0. We then say over, we're going to do 1 minus negative 1. 1 minus the negative 1. And when we do this calculation, we're going to get 1 minus 0, which is 1, over 1 minus minus 1, which turns into a plus, is 2. The slopes are the same. Perfect. So we can say, therefore, yes, these are collinear. They do share the same slope. If you can confirm that these points share the same slope, collinear. That means they share the same line. Okay, slope-intercept form. Slope-intercept form is the only equation we dealt with in all of this unit. When we talked about relations, the equation of a line was always determined by the exact same equation. Y is equal to mx plus b, where m is the slope and where b is the y-intercept. Okay, so when we go to each of these, it's actually pretty easy to identify as long as it's in that form, y equals mx plus b. If it is not in y equals mx plus b, you have to put it in that form. Okay, so first one, our slope is our m value. Well, our slope is actually just the one attached to the x. It's 2. Our y-intercept, that's the one on its own. It's the constant term, so it is negative 7. We go on to the next example. It's 3 and 4, which is our slope because it's attached to the x. It's the coefficient of the x. And then our constant term is the negative 1. We scroll down even more here to line 3. We have what seemingly looks like no x involved. And if there's no x involved, we know that the slope is actually 0 because it's a non-existent slope. So we can say slope is 0. There's no m value. M is equal to 0. What is the constant term? Negative 5, which becomes our y-intercept. Now, we go to the opposite example. Now we have some term with x, but no constant. Well, the slope is always attached to the x, and it is the coefficient, so it's 4. But there's nothing here. It's plus 0. So the y-intercept is simply just 0. Lastly, we have a negative 4 over 3 attached to this x. That is our slope. We have a negative 4 over 3 slope. And then the constant term that's here, we include its sign, and it is 4 for the y-intercept. So just remember, if it's not in that form, y equals mx plus b, you have to make it in that form, then plot it. Okay, now what they want you to do is they want you to take these and plot them on the graph, which I might not do for this. Honestly, I think that you'll be able to take it from here where we have our slopes and our y-intercept, and you could solve it from there. For the sake of this, maybe I'll just do the first 2 lines just to make sure you have the concept, and then I'll allow you to continue forward in your studying. So let's say I want to plot line 1. Well, it has a slope of 2, a y-intercept of negative 7. I'm going to go down to negative 7. 1, 2, 3, 4, 5, 6, 7. Because we have to remember, this is x, this is y. Okay, I go down to -7. Here's my first point. It is a slope of +2, which is like writing 2 over 1. I have to go up 2 units over 1. There's another point. Up 2 units over 1. There's my third point. Up 2 units over 1. And so I could create a line segment that contains all of these, and I will call it line 1, and even put arrows on the end because this could extend infinitely. All right, now, in terms of slope for line 2, which is 3 over 4 with a y-intercept of -1, I'm going to do this in red. A y-intercept at -1 puts me here at -1. And then if I have a slope of 3 over 4, that's a positive slope, meaning from left to right it should be increasing. I go up 3 units. My change in y is 3 over 1, 2, 3, 4 units for my run. Now, I'm going to go up another 3 units over 1, 2, 3, 4. There's my third point. What I can do is I can create a line segment that goes right through those. And I'll put arrows on the end because I know it can extend. And then I'm going to call this L2, just like I should have called this one L1. So your first goal is plot that y-intercept or x-intercept or whatever they give you. Most likely it's the y-intercept. Then use the slope to help you get another 1 or 2 points and connect those lines. All right, now, opposite case scenario, they say, what if I just give you a bunch of lines scattered all together? Can you put them back into the equation for the line given just purely the graph? So that sounds a lot complicated, but we're going to break it down. What if I look at A here? Well, first of all, they say, what is the slope and y-intercept? Well, the y-intercept of A occurs right here, which is at y is equal to +1. So in that space right here, I'm going to put +1. The slope, I'm going to calculate between any two given points. Let's say I go between here and here. Well, right away I'm thinking because it goes left to right in a decreasing order, we have to assume that it's going to be a negative slope. Let's do that. From here to here, it goes down 1, 2, 3, 4 units negative. It then goes over 1, 2 units positive, meaning a slope is equal to -4 over 2, which simplifies to -2. So now in my slope formula here, I'm going to go -2, and the equation is equal to y is equal to mx plus b. Remember, that's always our same equation, y equals mx plus b, where our slope is m, so -2x, and then plus our y-intercept. All right, we're going to go to b. B does the exact same thing, except our y-intercept is at 0. It's at the origin. So we're going to scroll back here, and we're just going to fill this. Maybe I'll zoom out a little bit, and that might help me just look at both of them at once here. I'm going to say our y-intercept of 0. Our slope is equal to, well, let's say I go between this point and let's say between here and here. Well, I have to go up 1, 2, 3, 4, 5, and 6 units vertically, and over 1. That means I have a slope value of 6 over 1, which is just equal to 6. So when I go back to my chart, I'm going to say 6, and y is equal to our slope, which is 6x. And do I really need to put a +0 here? No, that's not going to change much. So we know if our y-intercept is 0, we don't really need to put b there. Okay, c. When I look at c, I'm going to look at the y-intercept, which appears at +3. So I'm going to go to my chart and put that in, +3. I'm then going to look at the slope and say, let's say I consider this point to this point, because it doesn't really matter which points we use. I go up 2 units over by 4 units. And let's just double check. 1, 2, 3, 4. Yes. So my slope is equal to 2 over 4, which is equal to 1/2. Okay, so now in my chart here, I'm going to put in +1/2, and that should make sense. If I see something increasing from left to right, it is positive. And now in my equation, it's y is equal to 1/2 times x plus the b value, which is 3. D, I automatically see this as a negative slope. As soon as I see that negative or left to right decrease, I know that's a negative slope. The y-intercept is at -5, so I'm going to put that in my chart right away. Now I want to calculate the slope. I can use any 2 points. Like even if I wanted to use this one and this one, well, we go down 1 unit over by 4. -1 unit over by 4. The slope is equal to -1 over 4, which can't be reduced anymore. So we go to our chart and we say this is a -1/4. Now, remember what we talked about when it comes to steepness of the lines? Well, the greater the slope, the more vertical the line should be. Do you realize how that B is the most vertically up and down, and it has a really large slope? It has 6. Versus D, which has a quarter, it's a less than 1 value, but specifically a very low value. It's basically horizontal. So the greater the slope, the more vertical. The less the slope, the more horizontal. Now, putting in the equation, y is equal to -1/4 x minus whatever that b value is. Because it's a negative sign, so we're going to put the negative. Now, e, we're going to throw out a couple predictions here. So e is a positive slope because as it goes left to right, it increases. Because of its steepness, I would say that the slope is going to be something greater than 1. And then we have a y-intercept of here, which is going to be -3. So we're going to go to our chart and we're going to put in a y-intercept of -3. We're going to look at the slope, which is going to say, let's consider this point, maybe this point. We rise to over 1, 2 over 1. Therefore, the slope is equal to 2 over 1, which is equal to 2. Okay, so just like our prediction, because it's fairly vertical, this is going to be a greater number than 1. Most likely something in the 2, 3, 4 in that range, but it is 2 in this case. And then we're going to put this together. Y is equal to the slope of 2 minus our y-intercept. All right, now with this chart, what they want us to do is, this was appeared on one of your quizzes and it's definitely a good review for you. It's saying, what if I don't give you any graph and I want you to take an equation that's not in slope-intercept form and then see if you can put it in slope-intercept and determine some information from it. So what we're going to do right away is we're going to convert each of these equations in terms of y equals mx plus b. The star equation we dealt with in this entire unit is y is equal to mx plus b. If things don't look like y equals mx plus b, I'm sorry, but you're off to a bad start. We need to make that thing look like this, y equals mx plus b. So in the first one, we're going to use our equations knowledge and isolate for y. To start this, what I'm going to do is I'm going to say, if I add 5y across, that's going to give me an equation of 4x plus 20 is equal to 5y. Now, we're almost there because y equals mx plus b is the form we want. What's the only thing we got to do now? Divide by 5 to both sides. Okay, when I divide by 5 to both sides, I'm going to get y is equal to, because remember, those 5s go away. They simplify to 1. I get 4x over 5 plus 20 divided by 5 is 4. So now my equation in slope-intercept form is y is equal to 4 over 5 times x plus 4. Because you could either put that x in the numerator like this or out in front. Either way, it means the same thing. Now, easy to pull apart here. All we need to say is, well, what is our x and y intercepts? Remember, x-intercepts occur when y is equal to 0. Y-intercepts occur when x is equal to 0, and the slope's given to us in the equation. It is actually 4 over 5, or the m value. But to calculate our x-intercepts, let's let y equal 0. 0 is equal to 4x over 5 plus 4. I'm going to multiply both sides by 5 to get that 5 out of the denominator. Therefore, I'm going to get 0 is equal to 4x because the 5 and the 5 go away. 5, remember, has to distribute to both of these, giving me plus 20. I'm going to subtract 20 across, getting me negative 20 is equal to 4x. I divide both sides by 4, and therefore I get x is equal to negative 5. There's my x-intercept. Now, my y-intercept is the same type of form, except I'm just going to let x equal 0. Y is equal to 4 over 5 times 0 plus 4. Well, this part just goes away because anything times 0 is just 0. And y-intercept is therefore 4. And we should know that because our y-intercept always is the b value. If you have to write this, it is always our b value in the equation. So if we can get in y equals mx plus b, what we could actually do for all these equations is just right away put whatever the b value is for our value there. Okay. Now, we go down to this equation, a little bit of algebraic work needed to get into y equals mx plus b. I'm going to start by subtracting 7. Then, I get x minus 7 is equal to 3y. Therefore, when I divide by 3 on both sides, this is my resulting equation. Y is equal to, now, if I divide by 3 on this side, those go away, and I'm going to be given x over 3 minus 7 over 3. I've just split that fraction up. Okay. Now, in terms of the equation, we've actually just found it here. Y equals x over 3 minus 7 over 3. Perfect. And then from here, what I'm going to do is I'm going to say, if I have this form, well, to determine my x-intercept, y has to be equal to 0. So x over 3 minus 7 over 3. I'm going to add the 7 over 3 across to both sides. Okay, that's going to give me 7 over 3 is equal to x over 3. And now they have the same denominator. I could technically cross multiply these and then divide away the 3. Or I could just realize that if they both share that denominator of 3, I can just cancel those out. They go away. And you would actually find that if you did the algebra behind it. But if they share the same denominator like this, just get rid of them. Now, we know x-intercept is equal to 7. Our b value is our y-intercept. Our b value was actually this part here. It's the negative 7 over 3. Therefore, the y-intercept is negative 7 over 3. What was our slope? It was the coefficient of the x term, 1 over 3. Because technically, I could write a 1 here if I really wanted to. So it is equal to 1 over 3 and positive. All right, last one in this chart here. We're going to look at this and we see there's an x in the denominator. How do we get that out? We know we have to multiply both sides by x. When we multiply both sides by x, I get 2x is equal to y minus 3 because we know the x disappears from the right. And then if I want to get rid of that 3 and isolate for y, I just add 3. Therefore, I get y is equal to 2x plus 3. So my equation in terms of slope form is 2x plus 3. And now, when I want my x-intercept, I have to set y to 0 and isolate for x plus 3. I'm going to subtract the 3 across. That's going to give me negative 3 is equal to 2x. And then I'm going to divide both sides by the coefficient of x. Therefore, x-intercept is negative 3 over 2. Now, I go to my last part, and this was the y-intercept. The y-intercept was actually just our b value. Remember, it's always just the b or the constant in our equation. As long as it's y equals mx plus b, we say that our y-intercept is the b value, which is 3. And our slope is always the coefficient m, or the coefficient of x. So our slope is 2. There we go. So the hardest part about this is using our equation knowledge to help us isolate for the equation. Once we isolate for the equation, I'm 100% confident you'll do very, very well filling out the rest of this. But we just need to memorize that we need it in terms of y equals mx plus b. And then the other critical piece is when we have an x-intercept, y is 0. When we have a y-intercept, x is 0. Okay. Determine the equation of the line of the following conditions. So they're going to give us a condition, a point, and then they're going to say, hey, what is the line? Okay, determine the equation of the line. We know the equation is always y equals mx plus b. Remember, that's the gold standard of this unit. We always want it in this form. Now, I want you to remember that y equals mx plus b is only used when the slope is defined. So we're going to see an example potentially where the slope isn't defined, and how do we adjust our equation? A horizontal line through the point of this. Well, what does a horizontal line tell us about the slope? A horizontal line means that the m, or the slope value, is 0. It is a line that's directly across, meaning there's no change in y. So what is this equation? Well, the equation is then clearly defined by whatever the y value is, because when we do y equals mx plus b, the slope is 0. And so that goes away. What is our y-intercept? It's just whatever the y value is. Or our b value, it's negative 7. So we say that our equation, therefore, is y is equal to negative 7. It is just a horizontal line cutting through negative 7. A vertical line through the point this. Well, a vertical line means the slope is undefined. And if the slope is undefined, then this line can't be described using y equals mx plus b. Because if it's a vertical line and it never crosses through the or it doesn't have a y-intercept, and on top of that a slope isn't defined, how does this equation make sense? If we do y equals mx plus b, well, first of all, this doesn't even exist. It's an absolute no-go because there's no slope. And it will never cross the y-axis because it's a direct vertical line. So in this case, the y equals whatever doesn't make sense. We have to say, therefore, it's x is equal to whatever the x value is. That's for a vertical line. It's always defined by x is equal to whatever the x value is. Finally, a horizontal line that runs through the origin. So let's actually pictorially draw this one here. If I draw this pictorially, a horizontal line that runs through the origin. We have to remember that the origin occurs when x and y are both 0, 0. So 0 and 0, and it is this point here. The only possible line that would run through that is this here, right along the x-axis. So therefore, using our knowledge about saying, well, if we have the equation y equals mx plus b, and we know that the slope is 0 because they said it was a horizontal line. As soon as I see that, I'm like, hey, slope is equal to 0, meaning this part is 0. Then what is my y-intercept at the origin? It's whatever the y value is, in this case 0. And my equation of this line is, therefore, y is equal to whatever that b value is, which is 0. There is my equation for this line in red. Y is equal to 0. All right. Now, Torvald uses an equation to produce the following ordered pairs. Which equation describes this list? So a really easy way to do this problem would just be to simply say, okay, if I plug in the points or the data points between this, I could figure this out. The other thing is I could say, because you could do this quite easily with guess and check, take x values from here and then just plug them into the equations and see what the outputs are. Or we could think about this more theoretically. When x equals 0 and we have some y value, this is the y-intercept. They're telling us the y-intercept, which is equal to the b value. The b value is -3. When x equals 0, we have our y-intercept. That's that connection point there. So we have a b value. Now we just need to calculate the slope. What is the change in y between points? What is the change in x? So when I go from here, I'm going to do the slope in blue. M is equal to, let this be 0.1, this 0.2. My y2 is -3 minus my y1, which is 7, or -7. My x2 is 0 minus my x1, which is -2. Therefore, I get -3 minus minus, which turns into a positive, and this would be -3 plus 7, which is 4, over 0 minus minus 2, which is a positive. And this reduces down to m is equal to 2. So now when we go to our list, this is really easy. We have two values that we needed, m and b. Which one has an m value of 2 and a b value of -3? That is C. So we can circle C and say that that is the correct answer here. All right, which of these equations represent a line with an x-intercept of -3 and a y-intercept of 4? Well, right away, an x-intercept is more algebraic. A y-intercept, though, we know a y-intercept is symbolized by the b value. So when we look at any of these equations, we need to look for the one that has a +4 for the b value, meaning these two answers are right, they're gone right away. Their b values are -3. So if they have a b value of -3, which is their y-intercept, that's not true. Now we're looking at C and D, and we want to say which one has an x-intercept of -3. Well, we just got to do a little bit of algebraic work here. For both of these equations, what you have to do is say, okay, y is equal to 0, which leaves me with -4 over 3x plus 4. Now we're going to do the algebraic work of multiply them both by 3. That's going to leave me with 0 is equal to -4 over 3x plus 4. I'm going to subtract 4 to the other side, which is going to give me -4 is equal to -4 over 3x, which is -12 is equal to -4x. I divide both sides by the -4, and -12 divided by a -4 gives me an x value. Therefore, x is equal to 3. Now, right away by process of elimination, if I got a -3 for this solution, but we're looking for or if we got a +3 and I'm looking for a -3, then it must just be the other one in the 50-50 at this point. D would be the correct answer here. So as soon as you see that and you get the positive, and we know it's between a 50-50, just go to the other answer. All right, Tim plotted these 2 points, 2 and 4 and 6 and 10. What is the equation of the line that passes through both of these points? Okay, so we're going to have to determine a couple things here. We not only need to determine the y-intercept, but we also need to determine the slope of this formula. So what we're going to do is we're going to determine the slope, which will help us narrow this down to a 50-50, and then we can figure out the y-intercept from there, or the b value. So with these, anytime you're given 2 points, just go 1 and 2. Okay, m, or our slope, is equal to y2 comes from here, and it's 10, minus y1, which is 4. 10 minus 4 all over, and now we're going to go x2, which is 6, minus x1. 6 minus 2. Therefore, this is 6 over 4, which reduces down to 3 over 2. So right away, we know the slope is 3 over 2, which eliminates 2 of the answers, A and B. We then have to say, okay, well, if we know that the equation is y is equal to mx plus b, and we now know our equation, y equals 3 over 2x plus b, now just choose either one of these points, 2 and 4 or 6 and 10, because remember, these represent an xy ordered pair. Okay, so off to the side here. Now, I'm going to sub in, let's say I'm going to highlight the point I use, 2 and 4. If I sub in 4 for y is equal to 3 over 2 times 2, which is x, plus b, now it's just, we have to isolate for b. If we have 4 is equal to 3 over 2 times 2, 2 over 2 cancel, and I'm left with 4 equals 3 plus b. I subtract away 3 from both sides, and therefore I get a b value equal to 1. So my equation, when put all together, is y is equal to 3 over 2x plus the b value. That's the equation I'm looking for. Therefore, my answer is C. All right, rate of change in applications. So rate of change is saying, if I have one unit and I'm comparing it to another, what do I get out of this? So in this first one, we're going to give a graph of distance from home with John's distance from home versus his time. John left his home and walked 3 blocks to his school as shown in the accompanying graph. What is one possible interpretation of the section of the graph from point B to C? B to C is right here. Now, if he's traveled some distance away from home, and we can see that it's getting further and further, and then all of a sudden it stagnates, but time is still going. What is he doing at B and C? He's actually taking a rest. So what we need to look for is the answer where he's talking about a rest here. So John arrived at the school and stayed throughout the day. I mean, definitely plausible for sure. John waited before crossing a busy street. I mean, that's another potential. John returned home to get to his mathematics homework. I wouldn't say so. John reached the top of the hill and then began walking on level ground. Right away, I'm going to cross out a couple answers here. It doesn't make sense that he reached the top and then now he's just walking it on level ground. That seems weird because we're not talking about distance and height. John returned home? No, he's going to school. So that's not saying that he walked home. He's waiting before crossing a street, definitely plausible because he's on his way to school. John arrived and stayed throughout the day. That is not a long time period right there. I'm going to cross that one out. It has to be that he just took a break or stopped at the lights and was waiting to cross more. Because what we get in the problem here is that he left home and walked 3 blocks. That's all this is describing. It's not describing him going home or doing any other activity. It's saying he's walking to school, what's happening in that block. All right. The accompanying graph shows the time of water left in Rover's water dish over a time period. I'm assuming Rover is some sort of dog or some sort of pet. How long did Rover wait from the end of his first drink to the start of his second drink? Okay, so if we want to dissect this graph a little bit, well, we say, okay, the starting amount of water at time 0 was 400. 400 at time 0. It sits in the bowl, but then he takes his first drink. Then it sits in the bowl. He takes a second drink, sits in the bowl, takes a third drink till it is fully done. They say, how long did Rover wait from the end of his first drink to the start of his second? Well, the first drink takes place here. And then between the first drink and the second drink, which 1 and 2, it's this time period here. He is looking at this here. So what is the time? It's from 30 seconds to 60 seconds. That is the 30-second block between those two. So if you really wanted to label this for studying, you say this is 1, this is 2, this is 3, and this is just the water sitting between. So that's just the water that is in the bowl at any given time. And then 1, 2, and 3 represent where Rover is drinking. All right, the graph below shows Carlos's speed on his trip to school. Based on the graph, when is Carlos' speed decreasing most rapidly? So when time and speed are compared on these axes, we know that speed, it can fluctuate by a certain amount, but then we also know if it's related to time, then we need to say what one has the greatest rise over run. Because they're saying, and more specifically even, they're saying when is it decreasing the most rapidly? So in the green here, I'm going to talk about all the areas where he's increasing speed. Increasing speed, increasing speed, increasing speed. But then he is decreasing speed at all the yellow pieces here. These are seen as negatives, which I'll put here. Negative, negative, negative. The greens are all the positives. He is increasing speed. So where is his speed decreasing the most rapidly? It's the one with the greatest rate of change. The greatest rate of change appears along this line where the blue is. This is our greatest rate of change. And more specifically, greatest rate of change of decreasing. This is decreasing. Because on the y-axis, we clearly see it's going from left to right downwards. And then we're seeing that it's happening in a very short time period. So when they say decreasing the most rapidly, when we talk about the points here, we need to say that it is between this point here, which is point D, and then between this point, which is point E. So of the answers here, for times between D and E, that would be the one there. All right, parallel and perpendicular lines. What is the equation of a line that is perpendicular to the line shown and goes through point 3 and -1? Now, here's what I want you to remember about perpendicular and parallel lines. So I'll write this right at the top here. Parallel, which is symbolized by two vertical lines like this, they have the same slope. They are the same slope. Perpendicular, however, which is symbolized by an upside down T, they have the negative reciprocal slopes. If one is slope 1 like this, then the negative reciprocal is the perpendicular, or -1 over that M1. Now we're going to see what this means in terms of an example here, and we're going to see that the reason we put an upside down T and for parallel we put lines that are like running side by side is that that's what they look like on the graph. So let's actually look at this. What equation is the line that's perpendicular to the line shows and goes through 3, -1? Well, right away, 3, -1, let's go plot that right here. 3 for x, -1 for y. And then we want it to be perpendicular. Well, what is the slope of the line that is given? The slope of the line that's given, let's say we compare this point here and then this point here. We have to rise by 3 units. We go over by 4 units. The slope is m is equal to 3 over 4. Therefore, the perpendicular slope, m2, and I'm going to symbolize it like this, m2 is equal to, we flip the fraction, 4 over 3, and we make it negative. So now, that's the slope I'm working with to make the rest of my red line here. I say, if I graph this, I'm going to go up or down 4 units, and then left or right 3 units. It depends on which way I do this. So let's say I go down, I'm going to go up 4 units actually. 1, 2, 3, 4, and then the negative applies to the 3. 1, 2, 3 this way. So I see a crossover point here, and I can draw a perpendicular line. Now, what's characteristic about perpendicular lines? They form a 90-degree angle. So if you were to guess this, you would know that a 90-degree angle, and I form the perfect T, there we go. There's my perpendicular line. Now, when we talk about the equation that represents this best, well, the y-intercept, I'm going to record all this. The perpendicular slope, m, is equal to -4/3. And the b value, or the y-intercept here, is equal to +3. So when we put that in an equation, we have to look for +3 and -4/3. That is actually b. Okay. Chen drew a line parallel, remember by that double line that's standing, parallel to RS, or the line segment shown, and it includes point T. So point T is on the parallel line. The equation that represents the line, well, we need to do the same thing. Between these 2 points, how much do I have to decrease by to get to the point? How much do I have to go over to get to that point? Well, between 3 and -3, I had to go down by 6 units. So I'm going to erase that. I go down by 6 units, over by, from -1 to 1, that's +2 units. All right, so in terms of a slope, m is equal to -6/2. M is equal to -3. Now we know that T is going to share the same slope as this. So I can go down 3 units, 1, 2, 3, over 1 unit, down 3 units, over 1 unit. So my 2 points that I can make that connect T and make this parallel is here. Now, I want you to memorize that, or remember that when we have parallel lines, the slope is the same. Of the graph T, m is equal to -3 as well. They run parallel and they never cross because they have the same slope. All right, and then which is the line? So we've done all that baseline work. Now what we need to figure out is, okay, well, we know the slope is -3, which they all have coincidentally, so that's one thing. But then what we want to do is we want to just guess based on what's happening in this graph. Well, I would make the assumption that this is going to have a y-intercept or some b value way above here. So the b is going to be equal to some number up here. And we could pretty much approximate that to 6. Because the other ones are +3, which the line definitely doesn't cross through here. So that's not true. And the other one was +1. The line doesn't cross through there either. So we can make an educated guess and say, yeah, based on the trajectory of this line, it's going to cross through +6 and have that slope. All right. Linear and nonlinear relationships. Why or why not? Well, to be a linear relationship, it has to have the form y equals mx plus b, or a consistent difference in points, some form of a pattern. If it's just randomly selected points, that is definitely not linear. Now, you could do a collinear test if you really wanted as well, but that's something that you can easily do by calculating slopes. Okay, so linear, nonlinear relations, here we go. I'll maybe just do a couple of these and then leave the rest for you because I have a belief that you can put these together, especially with your knowledge of slopes. So let's say I consider the first one. Well, there's definitely a set pattern between this to this. It is a set pattern of, hey, things are doubling. So it is ×2 and then ×2. And then from here to here, this is saying we have a difference of -7 to -5, which is +2 upwards. And then from here to here, this is a difference of, in this case, from -5 to -1, that's a difference of 4. So what we're seeing is that in the first column, it's doubling. In the second column, it doubles again for x's. And then from the y's, it's increasing by 2 and then increasing by 4. But it's not necessarily doubling. So in this case, I don't think we can consider this one linear because there's not a set pattern between the x's and the y's. Whereas these ones are adding 2. This one's adding 4. The other one is multiplying by that amount, multiplying by the other. Now, I guess we could consider this also if we really wanted to. We could consider this a +2 and then this is a +4. So if it is that, then yes, this would be linear. I think it is a fair approximation to say this is linear. Now, in the next one, when we want to get it in terms of y equals mx plus b, what I would do is multiply both sides by x. When I multiply both sides by x, I'm going to get y is equal to 2x. And remember, if nothing is written here as like a plus nothing, that actually means that the b value is 0. This definitely is linear because we have a degree 1 term. If we have a degree 1 term, we know it's linear. That is another indication. If you see degree 1, it is linear. Anything greater, no. Okay, with any sort of relationship, we know in order to be linear, it has to be 1-to-1, meaning I can't have like an x value that goes to two y values. That's not true. That's not even a function at that point. But the other thing we need to notice is that there's some sort of pattern here. So if we look at this, we would look at the fact that it goes from 3 to 1, 1 to 2, 2 to 4. So if we really wanted to, you could even make this visual just to make sure. I go x, I go y. And now, if I'm at 1, then I'm going to plot a point at 2. And then if I'm at 2, I plot a point at 4, which would be up here. So this would be 1 to 2, 2 to 4, which puts me about here. And then if I'm at 3, which is here, this would put me at 1. Now, there's definitely nothing linear about that because this thing is kind of just scattered points all over. And you should expect that when you have an input of x and an output of y, and there's no set correlation pattern, and in fact, it actually goes in the reverse direction as x increases, y is kind of all over the map, you know that it's just going to create discrete points that can be plotted. The next one, definitely not linear. This is actually quadratic, which we're actually going to learn a lot more in future math courses. But quadratic, this is some form of equation that's a degree 2 equation, meaning it has this form like this. Not saying that's the exact equation, but what we would see is that there's a degree 2 term. Remember from polynomials, degree 2 is determined by the exponent. If we have degree 2, or it looks like a parabola, like this, a U-shape, well, we didn't deal with anything that was parabolic, that was linear, so that makes no sense here. There's no such thing as this for being a linear line. It is strictly quadratic or something of degree 2. Domain and range. This one's a very important one. So right away, what I want to put down is continuous or not continuous, continuous or discrete. In the first one, we see that we have a solid line that runs and kind of makes this graph. That is definitely continuous because it connects all the points with a solid line, meaning I could break this graph down infinitesimally. Like I could have all these points, and I could even break it down further and put like little teeny micro lines that would represent like 1/10 of an x value, 1/8 of an x value, whatever it may be. Whereas the other one, we definitely know this is discrete. It's discrete because there is no line connecting them, first of all, and more importantly, there's one x value for every one y value. They're just plotted points in the Cartesian plane. When they're plotted points like this with no connection, it is definitely discrete. Now, domain and range. I'm going to put both set notation and interval notation. Okay, in this first one, the endpoints are solid. Solid means they are included. Now, I'm going to create kind of boundary lines here. It goes as high as +8, as low as -5. It goes as left as -8, as far as +6. There we go. We've encased this function. Now we just have to list out all these endpoints. In terms of interval notation, here's what we have. Domain, and maybe I'll have to zoom in and make this a little smaller. Domain. Well, we know that if it's included, it's a square bracket. It goes as far left, because we always think about left to right, or minimum to maximum value. -8 to, what is the largest x value? +6, and that is included. So our domain is determined by, in this case, -8 to 6, or the minimum to the maximum. Let's do the range in terms of interval, and then we'll do them both in terms of set. This graph goes as low on the y values. It's as low as -5. So we put -5 and it is included because of the solid point. And we put a square bracket. We then go, how high does this go? It goes as high as +8 and it's included, meaning there is a square bracket. Square is included, round is not included. Okay, now in terms of set notation, I'm going to try and make this so it's not super off. Maybe I'll do it off to the side here just to do it a little bit separately. So instead, we could put set notation, which is x, such that, well, what values of x does it lie between? It lies between, and I'm going to put greater than or equal to and less than or equal to because they're included. It goes as far as 6, but as low as -8. And then once it's out of that range, or once it's out of that, once it's in that interval, and we know that it's anywhere in between here, well, it can technically be any value in the real plane. It could be a really small decimal, it could be a negative, it could be a positive, whatever you want. Okay, range. We're going to put curly bracket, y, such that. Now, y is between two values. What value is y contained in? Well, it's greater than or equal to or less than or equal to. It's greater than or equal to -5. That's the lowest point. And it's less than the highest point, which is 8. So once it's between there, it can be any y value in the real plane, and therefore it is y is an element of the reals. Now, which one is more common in your future? For sure, we're going to deal with a lot of interval notation, especially on the diploma, for sure. On the diploma, you will deal with a ton of interval notation, but set notation becomes very big in university, if not in calculus as well. So what I would do is get familiar with both, because they are both very important. Answers could appear in either way, and you want to be familiar. Okay, now, in terms of our discrete graph, domain can only be written one way, and it's in set notation. Domain is curly brackets. We just list out all the x values that it exists at. One of the x values is 1, 2, 4, and 5. And we put commas between them all. 1, 2, 4, 5, close bracket, no repeats. Range, same thing. We're going to look at the y values. It goes at -1, -2, -4, -5. So we're going to go -1, -2, -4, -5, no repeats. If there was a repeat there, we would just only put one of those values and stop.